Okay, so let's get started. Today we have something exciting. Yevgen is going to be flexing some of his muscles, Russian strength. So he sent me a link by email. This is what he just published from the community edition. And it's just a starting point, but I thought it would be good to try it out. Shall I import it into my? Yeah, I'll just Control C. Import. And I can just put this in the big data meetup thing. Oops. Sure. There we go. So this is again.
Yeah, so this is just some preliminary example. So the story is the following: like in 1965, so Russian writer Mikhail Sholokhov was awarded the Nobel Prize for Literature for the book "And Quiet Flows the Don." In Russian, it sounds like Tichy Don. So Don is the name of a river. So it's a book about life and fate of Don Cossacks during the Russian Revolution, Civil War, and period of collectivization. And there was a suspicion that he didn't write this book because for the rest of his life he didn't write anything epic like this. So in 2007, Norwegian mathematician Niels Lidjord made a statistical analysis of Sholokhov texts, and he actually showed that Sholokhov wrote this book. And in January, I attended the lecture of this professor Niels Lidjord, where he showed the analysis. So in this notebook, I just tried to reproduce what he was talking about, and like it's just first attempt to create some frequency, so initial frequency tables which he started from. So I use this online library. This is where one can find some text open access. And so these two files, they are text files with this book's text, and it consists of 3 volumes. And this file is just another book written by Sholokhov, which was compared to this book, Quiet River Dawn. So first, how to upload these books into the Databricks file system. Should I run it? Or?
Try it. You have to left click and enter the cell.
So it's cool. You know, it's
Shift enter.
Shift enter.
Dash. Yeah, it's running.
Yeah, so there was one problem. So these books are encoded with this strange encoding system, which is like old. I think all Russian texts were encoded with this encoding, like, I don't know, 15, 20 years ago. So in order to work with these files in Databricks, I had to convert it into UTF-8. Yes.
And is icon V available already in the system?
Yes.
Okay.
So we'll just check if we have everything here. Yes, so we have two files. One is called Судьба человека, which means fate of a man. And the second is called Тихий Дон, which is a quiet river dawn. So now I copy it into Databricks file system. So now it's here. So now I start some processing. So this command, it reads this text file by lines, and actual text starts from the 24th line. So I just do some filter. So now
zip with index adds index for every line.
Yes, so zip index actually takes a line and that added a number of this line. So and then by filtering, I just remove the first 23 lines. Then all the punctuation which separate sentences, I replace with this ampersand. And all punctuation inside sentences, I just replace with like empty symbol, and then I replace it with space. And finally, I read it into an array, which I called sentences. Yeah, so now we see like, so this is a capital letter, next element is also start from capital letter, again, so for me it seems like I did everything correct. I don't know, maybe I should check. And now I try to count frequencies of the words in sentences. So I tried to make some, to split sentences into some categories, like sentences with words from 1 to 5, from 6 to 10, from 10 to 15, and so on, and like 50 plus. And then create a data frame with frequencies and like with categories and frequencies of these categories. So I did it with this command. Oh, here it is. Now I just, since I have to do this for both books, I think it's better to wrap the previous code in a function, and I call this function frequency count. Let's check if it works for the previous book. Yeah, so it reproduces the same result as was here. And now I use this whole text files. I apply it for the whole folder with my books. I just obtain books from a folder into this variable, not variable, value. And then I do this. So I take two items, since I have just two books, and then I took a name of a file, and then I apply my function to the name of the file. So now I have two data frames of these frequencies. There seems to be quite the same, of course, of the volume of the book.
So here the counts are, so 50 plus 2, the last row means there are...
It's like 141 sentences.
Yeah, at least 50 words.
Yes, at least 50 words. Yeah, so next step is to do statistics of this data frame. It's not so easy. And I don't know how to do statistics in Databricks so far. So, but yeah, at least some preliminary actions could be done.
Oh, this is awesome. So I think we'll do latent directly allocation maybe in a couple of weeks. You can just continue with LDA, for example. So that should allow you to scatter sentences that have similar feelings in the cluster, for example. Are there any questions for you?
I have a question about the loading data to Databricks. Like here we use wget.
Yeah.
That's quite easy, but there is also option to use data or database underscore in the panel.
Yeah.
But that one accepts only tables or it doesn't accept just text files. Like what's the option?
Yeah, so I think the other ways are you can just go to let's see, is it data? Yeah, go to data on the left, you know.
Yeah, I tried to use
little
it, but
pancake
it's
stack thing, yeah. And then just go to the tables plus thing, yeah, on the top, see what that does. Drop file, click the drop file or click here to upload. Then just upload some CSV file.
Yeah, but then it's
and then it'll give you a path, right? It'll get file store, give you a path to the file.
Yeah, that's clear. I tried to, but then it asks column names. It only seems to accept tables. It doesn't accept like text file or some regular files.
Well, so because if you use the c.text file method on the path to the file, then you have to process it as RDD and then turn it to a table. I think.
I'll try it, but it was not trivial.
Yeah, nothing is trivial until you do it the first time, right? And it keeps changing. So we'll I can help you, or maybe during Pika, if you have the exact problem, then I can sort it out. But that's just for little files that fit on your computer. So typically that's not going to be the case. So typically you will have the data already in some other file store, commercial store like S3. Then there are ways of getting that as well. I mean, that's also straightforward if you know what to do. It's just one cell. You have to put the right keys for the Amazon, and then it just mounts the Amazon's S3 file system, and it's immediately abstracted. It'll just be like DBFS, except you will use that. We may do those things because I will try to get it to Twitter analysis. We'll catch live streams in Twitter, and then maybe I'll do some stuff in that. Yeah, thanks a lot. Yeah, let's see. I mean, okay, let's just drop a file. I don't know. I have no idea. Let's see. My downloads folder is a complete zoo, right? So I'm trying to. Oh, well, let's see. Okay, here. This is a CSV file. In fact, I just did this recently. Yeah, you see, when you do that, you get this thing, right? I could preview table here because it's a CSV file, but okay, so, but I'm going to also copy this. Oops. I'm not sure I copied the whole thing, but so if I say preview table, and this is actually the output of the k-means algorithm from the other day. Table name, blah. Right, so you kind of try to do some figuring out on its own. So it probably will take everything as a string by default because, well, string is safe. You can always cast things to string. And then it's just given some table names. It's used comma as a delimiter. And you see this one's actually, yeah, it's used the first header, prediction, loudness, tempo, duration example, as a first row. So it hasn't figured out that that is the first header row. So then I guess let's try first row as header. Okay, then it does this. This is because it's CSV, right? So then, so this one I can say is integer because these are the cluster labels. I mean, you can take it as string and then do all the casting internally, like I showed you earlier. But let's, because this is already pre-formatted, let's make it easy. This is all doubles or floats. Okay, so that's, so once you do this with the well-formatted CSV file, I guess you just create real key means 1M songs LTD. Okay, loudness, tempo, duration, create table. Table names can only contain lowercase, alphanumeric, and underscore, and must start with the lowercase letter. Okay. Whatever, right? So, want something. So, okay, so that's okay. So this is literally the output from our prediction thing we were doing last week, right? So it's now in this format, and so this table should be available, yeah, for you. So the other thing I was going to, I don't know what's in my buffer now. Okay, see, this is that file store thing, right? So, I mean, I think this should do something, right? So let's just see if we can find. Let's see. Now I'm evaluating it. Yeah, it's pretty RDD of strings. You see, this is what I meant. Like you can just load some file in. Let's make sure we take an action. Take 3. Yeah, it's all right. Is this better now? I mean, you can upload a file and then process it with the SC method, or if it's already pre-formatted, mess around with the table thing.
That's right. Okay.
Yeah, I can help you too. It's always hard the first time. Okay, what's our plan for today? Okay, so I have pushed the latest archives. I think push. Yeah. So we should first grab them. So here's my. So I generally so if you go into this extra resources, there's all this stuff. I'm going to okay, so don't do this until it works for me. So we wanted to just go to the course repo and go to DBC archives in 2017. So we have to grab a couple things. So the parts, so this is the, so the way to do this, unfortunately, we have to first download it, and it'll download as, I'm just doing it for you guys. So leave it as the same name. So if you have one already, just replace it because it's just crude. So then go back to your community edition and remember you created the Scalable Data Science folder, so go in here and import that from the file. Right? Extra resources.dbc. It's about 1.6 MB. Right, so it has a lot more. So I wanted to spend a bit of time on simulation and Apache Spark data frames, playing with a random number generator. So some of that stuff is here. And I also put some linear algebra cheat sheet to babble between Scala, NumPy, R. So inside the programming guides, there is an SQL programming guide we're working on. It's not quite finished. So most probably either next lecture or the following week, I sort of, Ivan Sadikov and myself, we're sort of parse the entire SQL, almost the entire SQL programming guide for Spark 2.2 because it's important you understand at least the programming guide. So, but it's still under progress, so don't go there yet. Or you can go, but the links won't work yet. Okay, so now what else? So let's do the same for the SDS. So my suggestion is if you're playing around and changing things, please keep your own copy of the notebooks you're changing. So I'm going to kind of do the same, just because I'm changing the content from feedback from you. So once again, I will go back here and just grab the 2017 thing, download it.
Is this file supposed to have all the other?
Yes, so yeah, it's all the other stuff we want to do. And I'm updating things in the past as well a little bit, not too much, but so you'll see once we okay, so now I import it. So it's about 1.9 MB now, compressed, I guess. Workspace quota exceeded. This is what I was afraid of. Okay, so what should I do? So anyway, this is going to be a problem, right? I just, let's skip that happened. Yeah, I've got so many versions. So anyway, I'll see what delete. So you guys are not exceeding the workspace quota, right? Because you know you have to pay after a certain point. Okay, import. Oh. All right, I may have to do some other things. It's probably like registered and probably grows on a cron job to figure out size. So I'm going to work from my community edition, but everyone else has imported it, right? So I'll work from the academic shard. Okay, good. So what I wanted to start from is actually this one with the k-means clustering. And I would like you guys to, before we pick that, I thought you guys might really benefit from this collaborative calculator in the cloud. It's going to become possibly very important down the road anyway. So, has everyone gotten an account in the CoCalc thing?
No.
Okay, so so while I'm sort of talking about, maybe please go here, CoCalc. So I thought I said this in the so collaborative calculation in the cloud. This is free again, but it's very, very good for mathematical and statistical computing. COCALC.com. It even allows you to have like YouTube, not YouTube, what do you call it? Google Hangouts between each other and things like this. So it's very convenient, but not for that. The main reason is it's wrapping on top of SageMath Cloud, and so SageMath is one of the largest open source projects for mathematical and statistical computing. You know, it's quite thoughtful. So, and we would like this to be able to interactively visualize points in 3 dimensions from our k-means clustering for today, right? So that's the main reason. I think it's, yeah, just give your account and then just yeah, you can just register. Okay, so let's go back to this model thing. So a lot of people have questions. I wanted to clarify a few things before. Right, so we did this k-means clustering, which is dependent on the distances between pairs of points in 3 dimensions, and these distances themselves are defined by the where we place the points, and of course where we place the points is just where the features are, right? So what are the 3 features? So we notice that if we use loudness, tempo, and duration directly, we get a clustering. And when we look at the clustering in these pairwise projections, we notice that loudness and tempo are all mixed up, which may not be a sensible thing, because maybe if songs are clustered, maybe these 2 features should be separated, right? Because duration may not be the important thing to cluster, right? And also remember, when we looked at it, we sort of said the songs were getting longer in the 70s, you know, maybe due to hippies or whatever. So it's not like you know, it's not a sensible thing to bet our clustering on, right? Where is that stuff? Oh, it's in the ETL part. Remember the ETL part? We looked at the duration as a function of the year of the song, and there was an increase. So then this will be a typical problem. So the point is, not every k-means clustering is going to be sensible. So one thing we then tried is, let's now take then we looked at the univariate case, and then we realized, you know, there's like a skewed distribution. So then we did a log transform of the duration, and then that affected the complete global clustering. But then what happened was that the tempo and loudness were actually clustered separately, right? That's the second thing we did. So we looked at all of this. So just a quick recall. So then there was all this discussion about why is this together, and so okay, well, what I would like you to sort of make sure we all are on the same page is, we have something called the Euclidean space, and so our features are points in this 3 dimensions. So then when we project them onto this xz plane versus yz plane versus xy plane, those are those 3 scatter plots you're seeing, right? They're just these projections on the 3 sides of the wall, right? But the cloud of points is here. So you know, it's better to really get your hands dirty on this, because you know, so what I thought is, okay, let's just go to CoCalc and take a look at this. You know, so what I did is I simply downloaded, just like I showed you with the CSV file, I downloaded these. So if I go here, I think, right, you just have the table view of the same thing. So then I click this download button. I think like this, download CSV, and then I got some file, and then I uploaded it back to, actually this time I uploaded it to SageMath right? Or CoCalc. So that's what I did, and so now let's just jump in there. Leave this guy back to how it was. So those are those two data sets, the two data sets from with the log transform, without the log transform. So in those data sets, the first column is just this prediction column, and then the rest are just the features. So let's go here. Sorry, this one's what I wrote it. So then make this slightly bigger. So one can just sign into this. And if you don't have an account, you can get one. So is everyone here? Awesome. Oh, you guys are fast. Okay, good. So okay. So now so SageMath Cloud, I said, used to be CoCalc. So CoCalc is the new name for this. What's really nice about SageMath is that it's a nice, consistent unification of a whole lot of C, C++ packages through Python wrappers and Python as well. So you can do very, very powerful mathematical computing with Sage, right? So let's just open some docs. See, these are some frequently asked questions about Sage. So you can do arithmetic, geometry, number theory, cryptography, R, statistics for R, and a whole lot more, right? So it's very good, especially now. So here are these little manuals I've been looking at to make the 3D plots, so you don't have to really get into it too much. But basically, by calling this function point3D, 432, size 20, opacity 0.5, I can just create this this little plot. So this is actually just I think I have to make this smaller. So this is just a point in 3 dimensions, and it plots in JMO3, so you can visualize it. You can be able to right-click it and set some rotations and things like this. So that's very useful. Okay. And what I've done here is just plotted 1, 0, 0, 0, 1, 0, 0, 0, 1, and the sum of those three, right? It's vector addition. Just these 4 points, and they form the primitives for arithmetic in 3 dimensions. So you want to understand this. Pretty soon we'll get into some linear algebra, eigenvalues, eigenvectors, and so your geometry is important, at least in 2 and 3 dimensions. So that's all I'm plotting there. This is just a bunch of points you can plot as a list. So the sum operator is now acting on these image objects that are spit out by point 3D. So you just accrue the sum, accumulate the sum. Accumulate these images as sum, which is just overlaying, basically. So that's all that's done. So if I want, I can just do 100 points, and I just get 100 points slapped together. Okay, so it'll take some time. So here is what have we done now? I basically took points from the CSV file that I uploaded from my k-means algorithm, and once I've uploaded it, to upload it, basically you have to go to data and go to files maybe, and then you can just maybe try create. Let's see. File name. How do I do this? Oh, sorry, upload, and then you can just choose some file. right? Some CSV file and open it. It'll open here, and yeah, that's all I did. So once you have the file, then it'll tell you exactly where because I opened it in that directory, so I just put a // here. So it's saying in this directory, and this is the long name I gave for the file, just to be clear. So this is the k-means clusters from 1000 3D features, loudness, tempo, log duration, and I'm doing it read only. So those of you who don't know Python, don't worry about it. This is just basic Python. I'm just creating some clusters, some arrays here globally, and I'm just reading line by line and processing it. So don't worry if you don't know Python, but if you know Python, you know what I'm doing, okay? So I just created these clusters. So now I'm zipping these clusters. Remember, the clusters are tagged by 0 for the first cluster and 1 by the second cluster. So I've caught them separately. So now I'm just zipping them together. And then I can just plot them in 2D, right? So this is just a 2D plot. And I'm just plotting the other clusters in blue here. Just right. So then, and I'm just putting them both together here, right? So because I'm doing this plus equals operator, because the images, I'm just overlaying the two images and showing them. Okay. So I just grabbed the first few lines. So now you can see how. So these points are really sitting in 3 dimensions, and I'm just projecting to those particular 2 dimensions, right? So so if you want to use the primitive objects directly in 3D and plot these points in 3D and play around, then you know, let's just all this does is I just took the little thing I did in the block and put that into a Python function. So now we can call this Python function that will take a file name and the maximum number of points you want to plot, and then kind of abstract away stuff for us and return us these 6 arrays we want. That's all I'm doing here. So then here I'm just, okay, here's this really ugly list of 6 vectors that is spit out by this function. Now I'm giving the function this particular k-means clustering output from our Spark SQL job. And in this case, I'm only using the loudness, tempo, and log of the duration, the second example. Right? So I'm asking for all 1000 lines. So that should load up, and right, and then here is the other one. So I'm just mechanically calling them by different names. Okay, so now I want to know the minimum in each coordinate for both sets of features, right, with and without the log duration. So this is the minimum in each coordinate, and we're getting the maximum just to get the range of where these clouds of points in 3 dimensions are for each feature set. And then I'm just plotting. So now I'm just plotting it. And I've overlaid it for the cluster 0 and cluster 1. So I think you can play around, zoom in. I'm not so good with this mouse thing, but you know, you can see what I'm talking about. So these are points in 3 dimensions, and I haven't done the projections for you in each of these other 3 2-dimensional subspaces on the corners, but you can do that, right? You can just do that by essentially doing another point 3D and then putting 0 for the third coordinate you don't want to show, right? So you know, knock yourself out. This is just the same for the other one. And my point here is, if you stare into these 2 clusterings from the 2 different features, it's quite clear, right? The z-axis is preserved. So you see, this thing is breaking clouds this way, and this one was breaking it differently. And you know, of course, you know, there's TensorFlow, TensorBoard. I mean, there's a lot going on. I haven't had time to like dive into all this. So this is Google's TensorBoard. So this is for machine learning visualization. This is really out there. Like you can start playing around and how your neurons and your activating layers are all changing, and there's quite a lot going on, right? What is the other one recently Google did? It's yeah, there's another one from 2 weeks ago, right? Facets, I think. Is it facets? Doesn't even know. Yeah, visualization for ML data pair code. So this is like I haven't had time to get into all this, but this is super nice and cutting edge. And the concepts you've learned here, you should be able to do a lot more with these kinds of tools on top of it. Okay, so much for that. Right, and if you want to get into Sage, it's not that difficult. So for example, I had defined my fig, right? So you can do my fig and put and then it gives you, it's the same kind of dot operator, dot tab operations, and it will give you all the things you could do with that particular object, right? And then if you want just text output, you can just do this. Right? You can do whatever. It should give you a dot string usually. Let's see. Okay. Anyway, so this is how you get the docs, and of course, I've given you pointers to all the docs upstairs as well. So, are there any questions about? Okay. So we'll probably come back to Sage periodically for Sage map worksheets within CodeCalc. So if I show you here, let me see. So if I say create new, and these are all the different things I can choose from: Sage map worksheet, Jupyter notebook, Markdown, LaTeX, whatever. There's a few more. You can do R, Python, and so on. Okay. So let's go to, boy, I'm getting slow. It's already fika time. Okay, I'll at least tell you the plan in 1 minute, and then we'll try and get some fika bread. So I was going to go through linear algebra. I was going to play maybe Amit's video. Either we can play it here. It's like a 10-minute video, but it gives you all linear algebra in 10 minutes. It's worth listening to it. And then we'll just get into Scala, so you guys immediately start coding in a Scala Breeze, which is a linear algebra package for Scala. And then let's see where we go from there. From there, I have Introduction to Linear Algebra, which I would prefer you watch this video at home. It's an 11-minute video. And then I'll get you guys into distributed linear algebra, which is like how do you represent matrices that won't fit into single machines. And we'll probably do this tomorrow, I think. And then we'll come back to the power plant pipeline example we did, and hit it with linear regression with distributed linear algebra with the full. Does sound good? Okay.